Okay, let's unpack this. Welcome to the deep dive. Today, we're not just, looking at exam notes. We're really digging into the JN0-1103 concepts. And our mission, really, is to pull out the genuinely fascinating bits, the practical stuff you can actually use, especially around Juniper's Mist AI platform.
Yeah, and what's really interesting here, I think, is that these aren't just abstract ideas for a test. They show a real shift, a fundamental change in how networks are built and managed now, towards systems that are smarter, yeah, but also more robust, more aware of the user. We're trying to get beyond just the exam points to the why.
Right, the underlying principles. And just so you have the context, this exam, the JN0-1103, it's usually about 90 minutes, around 65 multiple choice questions. You take it through Pearson, VUE, standard stuff. But these details kind of matter because they show why these concepts we're about to discuss are considered so vital. It's like this is the baseline knowledge now for modern networking, the building blocks. So building blocks. Well, let's start right there. The architecture. This Mist architecture is seen as a key advantage. What exactly makes their approach, this microservices thing, so different? How does it really change things on the ground?
That's a great starting point because it really is foundational. Mist uses a microservices-based cloud architecture. Now, that's not just jargon. It means each bit of the network service, like, say, authentication or location stuff, runs as its own separate thing, an independent component.
Yeah, okay.
So think about the old way. One giant piece of software, right? If one little part had a glitch, the whole thing could potentially wobble or go down.
Right, the whole system update nightmare.
Exactly. But with microservices, you've got lots of smaller, specialized services running side by side independently. And the big advantage, like the source material says, is it enables independent feature updates without affecting other services. That's huge.
So you can update one piece without breaking everything else.
Precisely. It leads to much better resilience, much more flexibility. Think about it. Patching a security flaw or rolling out a new feature doesn't need a massive system reboot anymore. You can tweak or fix one service, and the others just keep running. That means less downtime, faster innovation. It's like changing a tire while the car's still moving. Almost.
Okay, I see the power there. But doesn't managing, dozens of tiny services get complicated? How do you keep that from becoming chaos for the IT folks?
That's a fair question, and that's where the intelligence of the platform comes into play. The architecture uses microservices, yeah, but the management layer is unified. You're not manually juggling each service. The system handles that orchestration. It hides that complexity, basically. So the IT teams can focus on results, on the user experience, not on wrestling with the infrastructure bits.
Right.
You get the resilience, the speed, without the management headache. Makes sense.
Yeah, that makes perfect sense. So intelligence. That leads us right into AI, doesn't it? We've all been there, network problems, super frustrating. How does artificial intelligence actually help fix things, like beyond just logging an error message?
Right, and this is where Marvis comes in. Marvis Virtual Network Assistant, that's Mist's AI engine, essentially. And its whole job is to flip network management on its head. From being reactive, waiting for things to break, fighting fires, to being proactive, predictive almost, managing network health.
Okay, proactive how?
Well, instead of waiting for you or a user to call the help desk, Marvis is constantly watching. It's analyzing just tons of data, telemetry from every device, every connection all the time. It spots issues, maybe slow Wi-Fi performance in one area, or connection failures, or even really subtle things that hint a problem is starting. But here's the key difference. It doesn't just wave a red flag. It often gives you smart suggestions, like really specific, actionable steps on how to fix the problem. Sometimes it can even fix things automatically.
Really?
Yeah, it's like having a super experienced network engineer watching everything 24/7, catching issues often before users even notice.
So it's not just, hey, something's wrong. It's here's what's wrong and here's likely how to fix it.
Exactly. Diagnosis and prescription.
Can you give an example? Like a tough problem Marvis solved? That would have been a real pain otherwise.
Oh, sure. The classic "my Wi-Fi is slow" complaint, right? Super vague.
Yeah.
The worst.
Totally. In the old days, that can mean days of digging through logs, checking APs, checking the client device, trying to reproduce it manually. Nightmare. Marvis, though, can look at that specific user's experience over time. It might see, okay, this person always has choppy video calls when they walk between floor 3 and 4.
Yeah. Then it correlates that with logs from the access points in that area, maybe RF interference data, and pinpoints. Hey, this AP might have a weird antenna setting, or there's non-Wi-Fi interference right here.
Wow.
It turns potentially days of guesswork into minutes of targeted action, often before that help desk ticket is even officially logged. That's a huge time saver.
Yeah, that completely changes the game. It's less about, is the network technically up, and more, is it actually working for the people using it?
Hmm.
Which leads perfectly to service level expectations, SLEs. How do you measure if Wi-Fi is good from that user perspective?
Exactly. And that's why SLEs are so important in the Mist world. They're the key metrics Mist uses to track performance, specifically from the user's viewpoint. It's a shift away from just, pinging an access point to see if it's online.
Right.
It measures things that actually affect whether someone has a good experience or a frustrating one.
Like what specifically?
Okay, so examples would be connection success rates. How often does your device connect smoothly on the first try? Or roaming performance. As you walk around, how seamlessly does your connection hand off between different APs? Is it smooth or jerky?
Mm.
Throughput and capacity too?
Mm.
Do you actually have the bandwidth you need for your apps? So connecting that back. SLEs give IT teams the power to proactively keep users happy. They see dips in performance as users would experience them and can fix things quickly. It's monitoring the human experience, really, not just the boxes.
I like that framing. Effective, not just available. Okay, sticking with user experience, but moving into the physical space. Indoor location tracking. That sounds pretty sci-fi. Why would a company deploy Mist's BLE array tech? What's the big win there?
Yeah, this is where digital and physical really start to blend in interesting ways. The BLE array technology uses Bluetooth low-energy signals, lots of them, in a coordinated way, and it uses them to pinpoint the location of devices or tagged assets indoors with pretty high accuracy. Think of it like an indoor GPS system, basically, because GPS doesn't work well inside buildings, right?
Right.
So this provides that accurate real-time location data inside. And the value is, well, it's huge, depending on the place.
Such as?
Well, imagine a hospital tracking vital medical gear. Where's the nearest infusion pump right now? Nurses save critical time.
Makes sense.
Or a big office space, maybe optimizing which desks are being used, guiding people to meeting rooms. Or a warehouse, tracking high-value inventory, guiding autonomous forklifts maybe.
Wow.
And it's not just finding stuff. It can trigger location-based alerts, like safety alerts in an emergency pointing to the nearest exit, or maybe a retail store sending you a coupon as you walk past a specific aisle. It really changes how you can interact with a physical space.
That's really fascinating. The efficiency gains alone, just knowing where critical things are,
Mm-hmm.
but also optimizing how people move, creating smarter environments. It's powerful. Okay, last area. Let's talk troubleshooting again, but those really annoying intermittent problems, the it works sometimes issues.
Right.
For the IT pro trying to solve that, what's the killer feature in the Mist dashboard for getting that historical view of just one person's connection?
Ah, you're talking about the client event timeline. That feature is a lifesaver for those kinds of problems.
Just so.
Because instead of relying on guesswork, or maybe a user's fuzzy memory of what happened when,
Yeah, it just stopped working.
exactly. The timeline shows you, visually, everything that happened to a specific device on the network over time. It's like a story, a chronological log. When did the device connect? Which AP did it join? How did it roam between APs? Were there authentication failures, DNS problems? Did application performance suddenly tank? It maps it all out.
So you get the whole picture for that one device's journey.
Precisely. A complete visual history. It makes spotting the root cause for those tricky intermittent blips so much easier. You often see patterns you'd completely miss just looking at isolated logs.
So the real power for the IT team is cutting through the noise,
Yeah.
getting straight to the actual problem.
Absolutely. It helps end the blame game.
Yeah.
Is it the network? Is it my laptop? Because the data is right there.
Right.
It speeds up fixing things, which makes users happier, obviously. And it frees up IT teams from endless troubleshooting loops to work on more strategic stuff. It's like that single pane of glass, but focus on one client's entire life on the network.
Think about how these advances, this network intelligence, this location awareness, it's not just for big company IT departments anymore. It's quietly reshaping how we interact with the physical world all around us. Our smart homes, public venues, hospitals, stores, they're becoming more responsive, more efficient because of this tech. So what new possibilities really open up when every connection, and maybe even every location, can be precisely monitored, understood, and optimized? When that line between digital and physical keeps getting blurrier,